Containers are great. There is no argument about that. And basically, even without containers, you used to do a lot of great things, right? You had a lot of application that you are managing, and with or without containers, you can run those applications inside your environment, inside your developer laptop, inside your different environment, including production, right? Even with or without container, the application run. So in this video, I'm going to talk about why you must use container. I'm not talking about all advantages that container bring. There are a lot of them, but in this video I just want to talk about the most important things that containers change in your current work culture, and why you must adapt the container practices for your project. So that's exactly what I'm going to talk about in this video. And as we are discussing, if you haven't subscribed to this video channel, please go ahead and subscribe. I would be posting a lot of videos like this that would give you a lot of advantage on, a lot of tips on how to use containers, what is DevOps, and learning DevOps, a lot of stuff I'm going to communicate through this channel. And please go ahead and subscribe to the channel if you haven't subscribed to this yet. So with that, let us start with our topic today. So there are a lot of solutions available today, right? Basically, even there are solutions such as serverless solutions as well in the cloud. For example, AWS Lambda is a great service where you can develop your functions and different small functions, and ability for these different services to talk to each other. All these things are available in the cloud, and there are many other solutions that allows you to develop your application. Even serverless solution that won't give you a lot of complications to manage your application. So why choose containers, right? Why don't you choose other solutions, and why you must choose containers? So one most important thing why everyone love container is it support any technology, and that is very important, right? There is no vendor lock-in. For example, if you are using AWS Lambda, you are happy when your technology support their technology and both work properly fine. But sometimes what you need is not what they offer, or probably a particular version of your application is not supported in Lambda. So or otherwise you should stick to what they have, right? So that kind of problem should come in when you go with some serverless solutions, including AWS Lambda. And even though they are great services, sometimes you might have requirement above that. So when it comes to containers, when you want to containerize your application or develop your application inside container don't care about what technology that you are using. It could be a Java based application, or it could be Python, it could be Go, it could be any programming language that you are using, and you want to run this application in any operating system. You might want to use different operating system libraries, maybe some Ubuntu package managers, or you might want to use some Red Hat package managers, or you want to use some Windows systems to run your applications. Basically, containers support almost everything. So whatever your application is, take the application, and whatever your application need, it could be the configurations, or it could be different settings, like such as storage devices, or it could be operating system libraries. Whatever your application need, you can put them all together inside a container, and you can run the container, right? And that is awesome. So most of the company will have more than one applications, and most of the application may be developed in different technologies, right? So it doesn't matter what the underlying technology is. Whatever application you have, it can still be containerized, and that is one biggest advantage of containers. It provides solution for all kind of application that your company manage. So, and that is a big thing, because think about a company who has different application running in different technology, and all these applications have different settings, right? They follow a different CI/CD pipelines, and the way how they run inside a server, it is different. For example, Java application, you must install Java, and it's a different checklist that you need the machine to have. And when it comes to a Python based application, you should set up the machine and the operating system to support this Python application, install all the modules that is needed, set up all the dependency, and make sure that the application application runs properly. And if you have lot of technology, different applications are using different technology, then it is a big headache for your operations team to manage different environment and different application to run across those environments. So but once you containerize them, then you have the container with you, and whenever you want to run the application, you just throw in those containers into various machines, and basically you don't need to set up anything on the server side, because everything you already developed inside the container. At the time of developing the application, the developer themselves, they put all the application requirement within the container. That would include your code, the configurations, then the operating system libraries, or any other dependencies that your application need. They are already available on the container, so you don't really have to worry about the technology underneath. Or the people at the operation side, they don't need to worry about all the technology different app containers are using. Basically, if there is a container runtime such as Docker or Containerd, you can run these containers in any machine you want, right? You can run it in developer laptop, you can run it anywhere. So that's one big advantage of containers. Since it support any technology, you can finally build all your application that your company have into a containers, and then change your workflow to match the container best practices, right? From then, so that's one big difference that containers make. Now the next thing what I want to talk about is the standardization, which is actually, the first one is what I wanted to emphasize, and remaining three things are actually different benefits of the first point, right? So as a company, you have a lot of application. Maybe assume you are using microservices, right? You develop your application as a combination of a number of microservices, 100 or thousands of microservices you want to run. And then once you containerize them, then you standardize the way how you want to manage them. Your workflow, once applications are containerized, you can follow a standard workflow for every application that your company on, independent of the technology underneath. So if I tell you one example, right, most of the time for a developer, it's just about creating a proper Docker file to build your application into a proper container image, and yes, with some proper optimization it can be achieved. And once you created the container, they can run anywhere. So where it can run, and most of the time you once the container images are created, you store them all together inside a central storage like a registry, and then the same container run in developer laptop. A developer want to preview their application, they just run the application in their laptop, and if they have Docker or any container runtime installed on their laptop, they can run the application with a single command. Developer don't need any help from the operation team to set up their laptop, because they don't need to install anything in their laptop except a container runtime. With that, they can run any application within their laptop. The QA engineer can do that in their laptop. Your security team, operations team, they all can, whenever they want to run application, they can run the application in their laptops just by taking those containers that you developed. And then you might want to, your CI/CD pipeline, want to create environments in the cloud. You want to create a dev environment or stage environment, or maybe a production environment, and in different environment you want to run your application. It is the same container that your developer have developed is what finally it will run in production. So there is no mismatch between the developer laptop and the production environment. Previously that was a big problem, right? It was very difficult to standardize the environment, right? Especially developer laptop and production environment, it's very difficult to standardize, because you have no control on what developers are doing and what is the kind of dependency that developer uses in their laptop. Sometimes it can vary, right? You have no control, and most of the time developers are not expert. They don't know how the production environment look like. So because of these problems, since operations and dev team used to work as independent teams before, it was developer might have different tools and technologies in their laptop, and then in production some libraries are different or some dependencies are different, and then something that work on developer laptop won't work in production. But with containers, it is the same container that developer develop is what you will run in production later, once it passes certain test, of course. So this way, the libraries, operating system libraries, binaries, the application code, dependency, configurations, everything is replicated directly from the developer laptop to every environment that your company have, then that is an awesome thing to do, right? So this would reduce errors a lot, right? And that standardization is one of the biggest achievement you got using containers, right? Very, very important. And another application of the containers is, basically it is very easy to orchestrate them. Once you brought yourself into a container culture, you would work in a different way than you used to work traditionally. So what that means is, now the environment management software installation has become much easier. You have 100 or 200 microservices. You follow the same practices to run these containers in different environment in your company. And most of the time you might be using tools such as Kubernetes or OpenShift or some tool that work around Kubernetes, and this orchestration tool can also be standardized, right? You can also your developer can do the development on a local Kubernetes cluster, and your dev environment can be another Kubernetes cluster where you want to run your testing stage environment, production environment. So you can use some kind of orchestrator tool to manage your container, and orchestrating your application using Kubernetes or a similar container orchestration tool is much easier than the traditional tool. So think about, there are a lot of things that you want to do when you develop or run your application in production. You want to make sure that the applications are restarted if they goes down, or the application scale automatically when more traffic is coming in. And then there are many things that you might want to do. You might want auto failover recovery stuff like that. Basically, some application fail, you want a new replica of the application to get created and replacing it. So there are a lot of things. You might want to scale up the CPU and memory in the cloud. So there are a bunch of things that you might want to do in an automated way. And when it comes to the deployment, you want to standardize a lot of things. And when it comes to containers, it is very easy, and it is a standardized process that you follow for every containers, for scaling, for configuration attachment. You want to provide configuration to the containers, it's pretty easy, right? You can use Kubernetes manifest, or you can use Helm or customize. You can use different manifest written as code, provide whatever the application need at the time of running them into your different environment. But think about if you are using traditional tools and you have some 200 microservices, and most microservices follow different technology, and you have hundreds or thousands of machine in production, and each machine might be installed with different software, and in order to set up that software in those machines, the machine should be made ready, right? The machine should run the operating system that the application support. It should have all the dependencies that the application need, including some kind of runtime, for example Java, if you are running a Java application. So you don't have to worry about all such kind of things. Just create an orchestrator and then just throw in the container into those orchestrator, then let the orchestrator do all kind of organizations for you. You just give the instructions, and so that way the orchestration of your application would become much easier if you are using containers. And then the last point that I want to talk about when it comes to integrating with the cloud. So nowadays most cloud providers provide a managed Kubernetes cluster. So what that means is, sometimes your software application would need storage, they need some networking services, because most microservices, they talk to each other over a network, and it is nobody but your cloud provider who provide this kind of network for the application to talk to each other, because there are hundreds of machines and applications are running as containers into different machines, and they want to talk to each other. So there should be a proper underlying network that should be provided. And sometimes you need some kind of load balancers to be created in the cloud. If you have some application that want to receive some external traffic, you might need some load balancers. So all these things that your application need, or sometimes you need some volume, right? If you have some state that you want to store and you don't want to store it inside the container, instead you want to store the state inside a disk in the cloud. So all these things can be done in Kubernetes. You don't really need to be an expert in the cloud, and any of these things you need to do manually. You can just manage all this infrastructure stuff within Kubernetes itself, right? Kubernetes support things such as load balance services, ingress services, then volume services, persistent volume integration services, networking integration services, a lot of services that your application needs something. You just write that inside your Kubernetes manifest, and rest of the things Kubernetes takes. Okay, Kubernetes talk to the cloud and provision the load balances, volumes, or whatever your application need in the cloud, it gets provisioned automatically. So that way it is well integrated with the cloud also. And then that is another advantage, and then there are many other advantages which I am not talking about in this video, but it can be extended. All this Kubernetes features or different container orchestration tool feature can be extended very easily, right? For example, you want a better strategy for managing your databases, you can actually create your own version of your extended. You can extend Kubernetes to add up those features. And then you want to implement GitOps practices. If you are using containers, then GitOps practices are much easier to implement. Or if you want to manage your configurations, Helm and Customize are very easy tool that simplify Kubernetes configurations. And basically, once you started using the containers, you get introduced to a world of lot of cloud native tools which make a lot of practices much easier than it used to be before. So that is one major reason why you should start using containers. And you cannot use containers starting from one day. I mean, you may have a lot of application in your company, and one day you cannot move them together, but a part of this may be. So probably, if you are not using containers, just explore some of them, try to move some of them into containers, and then just start enjoying those features that container brings to you. And that would be your biggest motivation to move rest of the application to the container. So do that, and let me know your feedback, and also let me know, I mean, if anything else that you want to add, go ahead and add. I could be wrong in certain points. What I discussed could be wrong, maybe right, maybe I am wrong. So let me know your comments, right? What are the extra suggestions that you want to put in, and any videos that you want me to do, just put in the comment. And also subscribe to this channel if you haven't subscribed it yet. Please go ahead and subscribe to this channel. I would be posting a lot of videos like this. Sometimes it could be something from my experience, or sometimes it could be some demonstration, some real-time demos, or it could be some DevOps roadmap, right? How you learn DevOps, things like that. So please subscribe to this channel and like this video if you think the video has helped. And also let me know any video or any practicals or anything that you want me to share next, right? So until then, see you, bye bye.